A próxima apresentação é do Luís Rodrigues, um habitué dos WordCamps, pelo menos lembro-me de tomar apresentações de há alguns anos, não sei se foi a única ou se já não foi todos. Hoje vai falarmos sobre aquilo que em tempos era feito no fim dos projetos, por pessoas que até aí não tinham ouvido falar nesse projeto e que ganhavam ao bug encontrado. Às vezes aconteceu. Pronto, sim, vamos falar de testes e novos paradigmas. Podemos chamar novas ideias já com uma dezena de anos e tal, mas que só agora parece que estão a entrar mais no mainstream destas coisas. Ele vai fazer a apresentação dele em inglês e, portanto, vou fazer a apresentação também em inglês. Our next guest is Luís Rodrigues, software engineer based here in Lisbon. We'll be talking about the concept that, although not new, is really becoming more prevalent in the software development world in general, and front-end web development in particular, and that is testing. So give a warm welcome to Luís.
Thank you. Okay, I'm going to be super brief because it's a big talk and I only have 20 minutes. So this is about React Testing Library. My name is Luís, like I was introduced. I used to do a lot of WordPress work, not anymore. So what the hell am I doing here? I work at a company called Equal Experts. Again, we don't do anything related to WordPress. We are a consultancy. We work with agile methodologies. We do a lot of stuff like extreme programming, pair programming, TDD. We try to get in with these flat structured teams, and we interact a lot with our clients to try to get a simple solution to their problems. So, what the hell does this have to do with WordPress? Well, one of the technologies that we've been working with is React, and React is prevalent everywhere, including WordPress, with Gutenberg blocks and even these headless CMS solutions that are starting to show up, where you have a WordPress that serves as a backend with GraphQL or REST, the REST API, that is then consumed by this JavaScript front end that's completely decoupled from the rest. And so React's been gaining a lot of traction in WordPress, and I said, no, why not? Let's talk about testing React components. And especially testing them with confidence. And front-end testing in particular has been a little bit of a boogeyman in software engineering because it's not trivial, or historically it hasn't been trivial. You can write tests for back-end logic. It's pretty simple. You know, a function takes something, should output something, you test it. Fine. But front-end, well, there's this web page, and there's this user flows, there's login, and there's state to maintain, state to test. And historically, you've been doing setting up some stacks with, for example, Selenium. I don't know if you've heard of it. So what Selenium does is it spins up a web browser, and you then control the web browser to navigate the page for you and test, if the page is correct. The problem with this is that it's a hell of a setup. Tests break if the page breaks for some reason. Tests are difficult to change. You're a pain in the ass, especially if you're using something like Gutenberg. And they're really, really slow because you're interacting with a real application and you are subject to all the delays and all the overhead that the application has with it. So you spin up the browser, you have to wait for it to load, and open the page, you have to wait for it to load. And if you just want to test like a stupid button or a form field, it's a lot of overhead. And this kind of, if you do TDD, you want these feedback cycles to be quick. You want to save the file, run the test automatically, and see if it fails, right, within a second, ideally. So we want tests to be readable, not these long Gutenberg tests like you used to write with Selenium or for Selenium. You want them to be robust. You don't want tests to break because, I don't know, a database failed somewhere and the site won't load. That's not good. And you want them to be maintainable because tests are your specification changes. You have to keep those tests up to date, and you want them to be fast. Okay, so specifically to React. There's a library that came up that was built on top of React test utils called Enzyme. And what Enzyme does is that it grabs your component, renders it in isolation, and you're able to test it. You don't need a browser to do it. It all happens in your testing framework. So it generates like this pseudo HTML structure, and then you click the button, you fill out the form, you press submit, you check that everything's been called, you check that your component tree has the right structure. And it's really readable, it's really convenient, it's really fast because you don't depend on the browser to test your application or your components. But there's a problem with Enzyme, in that its API, which is super powerful, but it does encourage some nasty practices. One of them is testing implementation defects. Primarily, it's something called shallow rendering. But there's also a few methods that allow you to inspect a component state and write assertions on it. And the component state is not something that's exposed to the outside world, and as such, you're not supposed to test. So what is shallow rendering? Shallow rendering, so let's suppose that we have this fake form that's built in React. You have a form, and then inside you have a component for a file upload, and an input field, the checkbox, and the submit button. And then the file upload behaves in such a way that when you drag a file onto it, it immediately starts a network request. Problem is, with unit tests, you want to unit test this, you have a side effect right here. So if you want to test the file uploads, you have to prevent or somehow intercept this request from being performed. So the solution is, well, the solution that Enzyme presents is you shallow render the form. So the form will fake render the file upload, the input, the checkbox, and the submit button. They're there, but not really. So when you interact with the file upload, it doesn't do any network requests. And you're able to inspect the form and say, well, I want my form to have a file upload, check. I want my form to have an input, check, and so on. And when I drag the file onto the file upload, I want callback so-and-so to be called. This never happens, you intercept it, everyone's happy. Until you have to change your form. If you put everything inside a field set, shallow render, then shallow renders the field set, not the rest. So all the tests that you had to check the file upload, the input and the checkbox will break, even though you didn't do anything that actually changed the form in any meaningful way, right? So then you have to do this nasty stuff called dive. You dive to force it to render or fake render the file upload, input, etc., etc. But this is like, you're not supposed to be changing tests when functionality doesn't change. You just moved stuff around. So this brittleness, you want to avoid it. And it limits your ability to refactor, really. It's the same thing with React components or functions. If you look too deeply into the implementation details of a function in order to test it automatically, if you look into the implementation details, if you mock internal dependencies, like you refactor something and the test will break for no reason, and then you get annoyed and say, screw these tests, I'm dropping them, not doing them again, because it's a pain in the butt. And you prevent yourself from refactoring the code, because I don't want to refactor this because it will break the tests. You can't do that. No, refactor is how you address technical debt. You don't want to be prevented, and tests should help you to refactor your code with confidence, knowing that stuff is not going to break. There's another problem. So this is what I talked about. There's another problem with this, is you have an internal component that's an external dependency, some module that you've pulled from an NPM or something like that. You're using it. With shallow rendering, you write your test in such a way that you don't have to interact with third-party component, which kind of makes sense. You're not supposed to test other people's code. But if that third-party component breaks, your application breaks with it, you have to make sure that whatever you include in there still works. So you don't have to test it, but you have to make sure, things are okay. So, does this mean that I have to write these integration tests for my components? Well, there's a bit of a... It's hard to describe what an integration test actually is. There's this, I think it was either Kent Beck or Martin Fowler, one of the Agile guys, who went to a workshop, and they asked around, what's your definition of an integration test? They got like 20 different answers. So it's a very fuzzy boundary between, on the testing pyramid. This testing pyramid means that if you test stuff through the UI, you get slower tests that cost more to maintain. Whereas if you write unit tests, which is like testing an individual function or an individual class or a module, then you get really fast tests that are very straightforward to read and cheap to maintain. Although you're not testing all the integration of things. But it's a very blurry thing. Some things we can agree on. So unit tests must run in isolation. A unit test must focus on a small part of the system, and a unit test must be fast. These things are generally agreed upon. Even the definition of unit test is kind of fuzzy. But what does unit mean? A lot of developers look at unit and think, now I have to test every function, I have to test every class, I have to test every isolated component, and that's not what a unit is. So when you adopt a strategy of testing your components using Enzyme, you go down this rabbit hole, and usually with not so good results, because you tend to test every single component that you have, even though you might not need to. So a unit is whatever makes sense to you, makes sense to your project. Even within a project, a certain component might require a unit test that's a little more higher level than the other ones. And if you adopt a different way to look at this, when you do test-driven development, you write the test before you write the implementation, right? Anyone familiar with TDD? Anyone does TDD? Okay. So you write one test for this, and then you write the implementation to make the test pass, then you write another test, and so on and so on. But when you write the test, you're not explicitly looking for dependencies. It's whatever it takes to make the test pass. It doesn't matter how many subcomponents, whether it's components or functions or whatever. It doesn't matter which subcomponents, whether they're first party or written by someone else. Like, you're not going to mock Lodash because you need a function from it. Just include it as if you had written the whole thing yourself. So, as long as the interface of your component or your function doesn't change, when I refactor it, tests should break. That's the ideal scenario here. Because, like I said, refactoring is key if you want to address technical debt later on. So when you write a test for a component, and then you rewrite the component to clean up the code to, make it more efficient, tests shouldn't break because the behavior doesn't change. So I'm skipping this because I read it. Okay. So enter React Testing Library. React Testing Library was actually the driver of what is now a family of testing libraries, not just React. And it was created by a guy called Kenzie Dodds. And he has this quote that tweeted, "The more your tests resemble the way your software is being used, the more confidence they can give you." And this testing your code from the perspective of the end user is really, really powerful. React Testing Library depends on JS DOM, which is bundled by default in a test runner like Jest. If you use Jest, it's just plug and play. Otherwise, it's mostly test runner agnostic, but you might have to do some work. And it provides a set of primitives that mimic this user behavior that you want to test. So for example, you have general queries. You can get something by the text. You can get something by its title, like the title attribute in HTML. You can get something by an alt text, like an image, or by its array role that you should include for accessibility. And same thing for fields, you can get an element by the label, you can get something by the value that it's displaying at the moment, or by the placeholder text. And this is like searching by text, or searching by a regular expression. There are no CSS selectors, you don't need to know whether the button is inside a div, or whether there's a class, a special class, or a special ID. It's the same way as a user. A user goes on your site or your application. They don't care if it's a div, if it has class X or the ID Y, right? But they do see the text, and that's the driver of these tests. So, is it a link? Is it a button? Who cares if it's clickable? There's an escape hatch. If you can't use text, you can set a test ID. And having a separate test ID, although not ideal, it's better than relying on something that's being used for something else. So if you have an ID that you use for your functionality, or a class that you use for styling, if you make your tests depend on that, like you're putting a chain around it, and you won't be able to later change that class without repercussions. And what you get back from these functions is the actual DOM nodes. Unlike Enzyme, which replaces object simulation with a bunch of confusing methods and structure, what you get back is the actual DOM nodes, as if you had run like a query select all in the browser, same thing. And then you can interact with it. You can fire events. Click, drag, double click, I don't know, whatever. Hover. So, example, this is from an actual project. You can see all the code, but it's pretty straightforward. So, what you're testing here is deleting something and then confirming it and making sure that deletion happens. You have a setup step. You get some test data. It doesn't matter what. We just care about the ID. You create a mock function that's called handle delete, and then you render using React testing library. You render your component, you pass it to fake data, you pass it to fake function, and you get these methods that you're going to use to interact with it. Then it's as simple as you click on anything that has delete on it, and then you wait for the confirm button to appear because it's a pop-up and maybe there's some animation or delay or something like that. And then you wait for the handle function to be called with the ID that you provided. That's it. Pretty straightforward to read or change even if anything changes, and it doesn't matter what you use to delete. Is it a link? Is it a button? It can change. It won't break the test because your test is focusing on what matters. So React Testing Library encourages you not test implementation details. It encourages good accessibility practices because it will force you to provide clear and ambiguous labels for your buttons. So if you have two buttons that are called delete, but do different things or slightly different things, maybe you need to work on that. And as well as adopting, area roles and stuff that you can actually use to query the elements on the page, as if you were an actual user. It's very simple. It's very lightweight. It's blazing fast. Enzyme is fast too, but this has a nice API. So there are some challenges that come with this. One of them is combinatorial explosion because you're testing the component at a higher level. Let's suppose that your form has some validation code in it. You would have to test the validation code through the form in all of its possible variations. So it can force you to write very similar tests for the same thing. It's something you should watch out for. Maybe it's worth testing the validation code in isolation and then just write a simple test to make sure that validation is going on for the form. You don't have to do everything. The idea is that there's some other brittleness where you change one thing and 10 tests break. So in our example, if your validation code broke, it would break all the tests for the component, even though it's not really related to the component, and it would be harder for you to determine exactly what was failing. and this unhelpful feedback will delay your debugging. So try to keep things as separate as possible. Unfortunately, there's no formula or a rule for this. You have to figure out what makes sense in the context of your project. There's a bunch of examples. You can go on React testing examples. It gives you a comparison between the same tests written for Enzyme and React testing library and other frameworks with and without, for example, Redux, which is quite popular, with internationalization, for example, which can be a challenge. So there's a few examples here if you're kind of lost and you don't know how to integrate this test with some other libraries in the React ecosystem. It's a pretty good resource. It's framework agnostic. It's based on something they call DOM testing library, which is under the hood. So if you don't use React at all, or if you don't use any particular library, you can still use DOM testing library, which gives you the same kind of APIs. There's for front for Angular, React, Svelte, Vue, also for stuff that isn't front-end specific. So if you use Cypress to do your end-to-end tests, you can use this. Gives you the same nice API where you can select by name. Also for Puppeteer and Test Cafe and for React Native, which isn't based on DOM at all. So I really love it, and it's got a delightful API. It discourages you from testing implementation details, which can lead to breaking tests and tests that break for no good reason. You want to have your tests to be clear and precise about what went wrong so that you can go there and fix it. And also it encourages accessibility in your components because it forces you to go through, to interact with your components and go through them as if you were an actual user. So either there's good verbal, textual cues in your component, or otherwise there's sufficient accessibility properties set, area roles, for example, to titles, alt text, and so on, to make sure that it's doing the correct thing. And it's not a silver bullet, it's not perfect. I mentioned some of the drawbacks. I mentioned a couple of ways you can get around them. There are trade-offs. So React testing library would be somewhere in the middle of this, not really, close to the bone unit testing, but it's a trade-off. And it's a trade-off that you have to make when you're writing your test. There is no formulas. You have to think about what you do and what you want to get out of tests. If you want to get out your tests to give you confidence in refactoring, confidence to deliver code without having to manually test all the time, and you want to get to a state where, for example, you write all of your components on your editor with unit tests running without ever opening the browser, and when you open the browser, everything just works. It's great. It's a great feeling. And you can do that with tests, but you have to be a little disciplined, because it's not just writing unit tests, it's writing the right unit tests. So figuring out where exactly you want to move is key here. And there's some great stuff here. It prevents you from making basic mistakes, unlike Enzyme does, and Enzyme is great, but it is a food can, and you don't want to shoot yourself in the foot. And that's it. Thank you very much.
I think we have time for one question.
Yes, a lot of pressure. 10 minutes, 1 more. Yep.
Hi, thanks. Thanks for giving the talk in English. What if you want to test a component that uses a Redux library? So it depends on with select, with dispatch. So it's not an isolated component.
It's not.
Strong dependency on the context.
Yeah, it depends on what test you want to write. You could write a single test that. So you could mock the Redux methods if you want. Also, you could leave the Redux methods in there and test everything through the component. Probably not ideal, but consider this. What if one day you want to replace Redux with something else? Then you have a bunch of tests that don't even care if it's Redux behind the scenes, right? And you could rewrite everything with, I don't know, React hooks and get you the same results without breaking the test. And that's pretty powerful. But on the other hand, it's like combinatorial explosion. If there's a lot of stuff going on in Redux, maybe you want to test some stuff directly, some reducers directly, or some middlewares directly, and try to find the right balance between on the React part of the rendering process, and whatever is more complicated or more complex, test it directly on Redux. But from my experience, we did in the project decide to move away from Redux, and having too many tests looking at Redux itself was a pain in the butt. We wanted to move away from it, and we had to rewrite all the tests to look at the component, and then we were free to actually start replacing some Redux with, for example, React hooks, which made code much simpler. But because we're testing Redux, not the component itself, not the application itself, it was tricky.
Okay, thank you, Luís.
Thank you.